the session so that those people who have questions will be able to see it. And let's try something here. Okay, so let's see. So I think, yeah, this is my section on 1.5 from the notes. And so what I'm going to do here is I'm going to write down the problem that we had, and then we'll walk ourselves through it. So the problem we had was pencil. Okay. So it was 4 minus 4, and then parentheses 2 to the third divided by the number -8. And so, guys, when I'm doing a problem like this here, so I'm going to follow my my order of operations. Okay. So number 1 says, let's do all operations inside the parentheses. So the first thing I want y'all to notice is I have 2 sets of parentheses. I have this 2 and I have this -8. But inside those parentheses, I'm not doing anything with my 2 and I'm not doing anything with my -8. So I'm going to go straight to number 2, which says raise numbers to a power. So this is the part that I'm going to do first, okay? So I'm going to write this as 4 minus 4. I'm going to leave my parentheses here. Now, guys, 2 to the third just means 2 times 2 times 2. So I know that 2 times 2 is 4, times 2 is 8, divided by -8, okay? Now, my next thing says we're going to multiply and we're going to divide our numbers in the order that they appear from left to right. Okay, so when I'm doing this, with this number 4 right here, I'm not doing anything with that number, it's just there. But when I have a number right here and a number next to in parentheses, the idea is the operation here really is multiplication. So I'm going to put a minus right here because there's a minus, and then I'm just going to say, well, what's 4 times 8? Well, 4 times 8 is 32, divided by a -8. Okay, we still have some division. So I'm going to think about this part right here. 4 minus, now 32 divided by -8. So guys, a positive divided by a negative is going to be a negative. And 8 goes into 32 4 times. And then my last step is, remember, if I'm subtracting, I leave the first number alone. I change the subtraction sign to a plus, and then I have to change this sign here. So that's going to be 4. So 4 plus 4 is going to leave me with 8. Okay. And so when I'm doing these types of problems now, I'm really going to try to go through those order of operations, those 4 steps, and making sure that I'm following each of those steps in that particular order. So Serena, did that make sense for number 6 out of 1.5?
Yes. I was just wondering. So if you have like the minus and then the -4 that automatically changes to a plus, is that like on every problem?
Yes, ma'am. Yes, ma'am, it is. So guys, this is an excellent question. I want you to think about, so I'm going to kind of move this over to the side, and I'm glad that Serena asked that question. So look, if I have 3 minus a -5, it's going to become 3. Remember, this sign always changes. So the subtraction always changes. And then I have to change this sign. So that's negative, it'll become positive. So my answer here would be 8. And if I have something like 11 minus -6, remember the first number, I leave it alone, 11. This becomes a plus, and I'm going to change this sign. So 11 plus 6 is 17. And I'm going to show you just a couple more because I want to make sure that we're good with this. So look, -13 minus a -2. Remember, this guy here never changes. -13. This becomes a plus, and then this becomes a +2. So I want you to think about this last part right here. Remember, if it's negative, think about this as money that I owe. So if I owe you $13 and I only pay you 2, well, then I'm still going to owe you 11, right? Now, guys, suppose I had the same types of problems, except these numbers here that I circled were not negative, right? So I'm gonna do the same problems, but look how I'm gonna write it. 3 minus 5. So I'm not gonna put a negative on the 5, right? Or I'm gonna go 11 minus 6, and I'm even gonna do negative 13 minus 2. Okay. So for these, I want you to think about it this way. I have $3. Think about it like this. I owe you 5. If I have $3 and I owe you 5, well, now I'm going to owe you 2 after I pay you. Or this is positive. So I have $11, but I owe you 6. And after I pay you the $6 that I owe you, I'm left with 5, right? And then the last one here, because this is negative, I owe you 13. I borrow $2 more. So now I owe you 15. So guys, it's been my experience that in dealing with positive and negative numbers, when it comes to adding and subtracting, if I can think of positives, how much money I have, and negatives, how much money I owe, it helps me understand on how to do these problems. At least helps me with the concept of what is my answer going to be? Is it going to be a positive number? Is it going to be a negative number? What's the actual answer going to be? Because I can kind of think out those scenarios in my head. Okay. So, Serena, did that answer your question? I'm sorry, about the signs.
Yes, thank you so much.
Okay, of course, yeah. Let's see, guys. Any other questions or any questions anybody has about anything else? I'm more than happy to answer any questions you guys might have. Okay, so guys, what I want to go ahead and do is when I was showing you guys what's due by tomorrow night, the last two sections that were due by tomorrow night are 2.1 and 2.2. And I want to go ahead and go over some of that material tonight or this afternoon. So this is my chapter 1 stuff. I'm going to kind of keep working here, moving along some more. Let me see, where are we? 1.8. Okay, so I'll tell you what I'm going to do. I'm actually going to do just a little bit of 1.7, and then I do want to jump into some of the stuff in chapter 2. So 1.7, I think this is an important section because this understanding 1.7 is going to help me understand the stuff in chapter 2. So 1.7 is combining like terms. So if you've had a chance to watch the videos, guys, here we have like terms, excuse me, and these are unlike terms. And one of the things what makes something a like term is the fact that they're both x's, or they're both xy's, or they're both x squareds. Okay, the numbers aren't important, but they have to have the same variable, the same letter, and if they have the same letter and if they have exponents, those exponents have to be the same. So these over here are unlike because one's an x, one's a y, one's an xy, and one's an xz, not exactly the same. This one's an x squared, and this one is just an x. So that's the reason why those are unlike. So what we're doing here is we're combining like terms. And just like I was explaining right now, guys, in terms of my numbers, so look, they're both x to the thirds. So the first thing I'm going to do right here, I'm going to write an x to the third. Okay. Now, I want you to look at the numbers in front. This is a negative 14. That means I owe you $14. And I am subtracting 21. That means I'm borrowing another $21. So if I already owed you 14 and I borrow another 21, well, now I'm going to owe you a total of 35. And because they were x to the thirds, that's why I'm writing an x to the third. Okay. When I look at the next one here, I have to be real careful to make sure that I'm understanding which are my like terms. So the ones that are actually like terms here are the 2b to the third and the minus 9b to the third. So your question might be, well, what am I going to do with this guy? I'm just going to write them down. 8b squared. Okay. Now, if I look at this one here, 2b to the third, that means I have $2 because it's a positive 2. But now I'm going to borrow 9. So if I only had $2 and I owed you 9, now I'm going to owe you 7. And because those are the b to the thirds, that's why I'm writing a b to the third. And because I owe it, if you notice, I'm putting a minus sign. So guys, as I'm going through these here, at any point in time, if I say something that doesn't make any sense, or if you have a question, please just interrupt me. You don't have to wait. You know, don't worry about if you're going to offend me by asking me or saying, sir, can you go over that again? I'm happy to go over it again, okay? So look, let's take a look at the next one here. 5x and a minus 6x. I have $5, but I owed you 6, so I'm going to owe you 1. Okay, and then minus 9b, minus 5b. So I owe you 9. I borrow 5 more. I now owe you 14. The only thing I'm going to say, guys, on this problem here, the order in which you put them is never important. Okay, the only thing that's important is we make sure that we have the right signs in front of the right pieces. Sometimes instead of writing a minus 1x, sometimes we just write it like this, just a negative x. But either way, it's the same thing, okay? They're both exactly the same. And let me keep scrolling here. Okay, so guys, for this one here, I'm really just going to use my calculator. Okay, so look, think about it this. 1.9 minus 3.8. So I'm just going to do this part here on my calculator. And if I go 1.9 minus 3.8, I'm going to get a negative 1.9 with an x. Okay. And I'll even show you how I'm going to do this on my calculator so you can see. Let me see if I can pull this up. There we go. Calculator. Okay. So let me show you the next part. So just to give you a heads up, this is a negative 2.4 and a negative 8.2. So let me show you how I'm going to do that part. Here we go. So we said a negative 2.4. Okay, so I just typed in 2.4. Then I'm going to hit negative. That made a negative. And then minus 9.2 equals negative 11.6. Okay, so I'm just entering in exactly as I had it there. And so let me stop sharing this part and come back to my notes so we can see that. And here we go. So we had a minus 11.6 with the letter B.
I think in the calculation you put 9.2.
Oh, okay. Yeah, you know what? You're right. So it's probably going to be 10.6. You're right. My bad. And it's 8.2, not 9.2. So 10.6. Yeah. Oops. Okay. Thank you. So guys, let's do the next one here. We'll go about it the same way. Okay, so I'm going to worry about my like terms. What kind of 6 is this? Positive or negative?
Positive.
Positive.
Yeah, and then the 11 is negative. So think about it this way. I have $6. I owe you 11. What happens? Anyone know? If I have 6, I owe you 11. Minus 5. You got it. Take it away. Perfect. All right. Now let's take a look at this one here. I'm just going to show you right there. So minus 5 minus 3. I already owe you 5, and I borrow another $3 from you. How much money would I have now?
Minus 8.
There you go. You got it with the Y. And then finally, guys, the last part here. Look, that's a positive 7 and a minus 5. So if I have $7 and I owe you 5 and I pay you the $5, do I still owe you money or am I left with money?
Left with money.
Yeah, we're left with money. So because we're left with money, it's a positive 2. Good. So guys, to me, this part right here is really important in understanding how to combine those like terms, because it's going to make the chapter 2 stuff seem so much better. So I'm going to kind of scroll down. I'm trying to see if I can find something. Here we go. I want to do a couple of these that at least have parentheses so that we can then move on to some of the others, okay? So let's take a look at this one, and we'll go about it the same way. So I'm going to multiply that first. So remember, I'm multiplying just the numbers. So I know that 8 times 3 is a 24 with an X. 8 times 2 is a 16 with a Y. And then 4 times 3 is a 12 with a Y. And 4 times 5 is a 20 with an x. And then now I'm just going to worry about combining my like terms. So I have a plus 24 and a minus 20, and that's going to leave me with a 4x. And then if I look at these parts here, so I owe you $16 and I only have 12, so I'm still going to owe you 4, okay, with the y. And let me go ahead and do these next two, and then, like I said, we'll move on to chapter 2. Okay, so we're going to multiply real slow. So I know that 3 times 2 is going to give me 6. And if I have one a here and another a here, now I have an a squared. Okay. And then we're going to do the same thing here. So I know that 3 times 3 is going to leave me with a 9. And then an a times a b, guys, that's just going to be an ab. Okay, I can't really do much with it. And then for the second part, we're going to go -3 times -5. So remember, a negative times a negative is a positive, and I still have that a squared. And if I don't see the number right here, guys, it's really understood to be a 1. So -3 times 1 is a -3, and then I have an a and a b. And now that I have my pieces together, then we can worry about combining them. So 6 and 15 is just 21 with an a squared. And then if I owed you 9 and I borrowed another 3, well, I'm now going to owe you 12, right? So let's take a look at this next one here. Again, I'm going to try to go in slow motion, guys, to do the same kind of thing. So -4 times 3 is a -12 with a c and a d. And -4 times 2 is a -8, and there's already a c squared there. And then let's do this part here, a 2c and a 5d. So 2 times 5 is 10, and then the c and the d just gives me another cd. And then again, if I don't see a number here, it's really understood to be 1. So 2 times 1 is a 2, and c with another c is a c squared. And now I'll worry about putting them together. Guys, the order in which I put them is not really important, okay? So I owe you $12 and I only have 10, so I'm going to owe you 2. And let's see, I owe you $8 and I borrowed 2 more, so now I owe you 10. So like I said, guys, the order is not important. So if you write it like this, or if you write it this way, it's the same thing, okay? It's the same thing. There's no difference between the two. Alrighty, and I'll kind of skip over that one. I'm trying to see if I can keep moving here. All right, I'm going to kind of jump over this section real quick because I do want to get to a little bit of chapter 2. And if we have some time, we can come back and do a little bit of that. Okay, so guys, chapter 2, this is like chapter 2 is going to be like the foundation of the algebra stuff for us. And so somebody in our class asked me, they had sent me a message, I think it was one day last week, asking me about like the TSI test and all that kind of good stuff. And like they were saying they need college algebra. And so one thing is, this stuff we're doing right here, guys, this is going to be like the foundation of the algebra stuff for us, okay? So this is when we're going to start getting into a little bit more algebra, and we're solving an equation. And so the idea here, guys, anytime we're solving an equation, we're trying to get the letter all by itself, okay? This is always the objective in solving the equation, is just trying to get the letter by itself. So the first problem here says, let's solve x plus 15 equals 21. Okay, so when I'm trying to solve a problem like this, the objective or the idea is, well, I have an x and a plus 15. So between the x and the 15, right now I'm adding those numbers. And what I want to do is I want to undo the process. So what I'm going to do is instead of adding 15, I'm going to go ahead and subtract 15 on both sides. So I'm going to bring this letter X down, and then this positive 15 and minus 15, they're going to cancel each other out. Because if I had $15 and I owed you $15, we'd be even. And then on this side, this is 21 minus 15. So 21 minus 15 is just going to leave me with 6. And we're done. We got the letter by itself. So the letter is over here on the left side by itself. It doesn't matter if it's on the left or the right side, as long as the letter is by itself. So I'm going to do the same thing for this next one. It's 23 equals 8 plus x. Okay, so guys, one thing I might do is I might say, look, let me write it like this. 23 equals. Remember, I'm adding here. And when I add two numbers, it doesn't really matter which number comes first or which number comes second. So I'm going to add it. I'm going to write it like this, x plus 8. And if I see, well, look, I'm adding the x and the 8. So let me go ahead and subtract the 8 on both sides. And then 23 minus 8 is just going to leave me with 15. And again, the letter is by itself. Again, it doesn't really matter if the letter is on the left side or the letter is on the right side. Really what matters is the letter by itself. Okay? All right. So this next one, it's x minus 13 equals 4. So if I'm subtracting 13, the opposite of that would be to add 13. And 4 and 13 is going to leave me with a 17. And guys, if I'm moving too fast or anything, please let me know, and I'll be more than happy to slow down. Or if something I do doesn't make sense, please let me know, and I'll go back and fix it. Okay. So let's see. If this is a plus 9, I'm going to go minus 9. And if I look at this piece here, remember what this means. I don't have any money, and I borrowed $9 from you. Well, I still owe $9, right? Okay. And so the next one here, we have an x minus 11. So I'm going to go a plus 11. A plus 11. And so let's see. I owe you $13, and I only have 11, so I owe you 2. So for this next one here, guys, it's a negative 16 plus x equals 47. Remember, I'm trying to undo the process. So if I have a minus 16 here, I'm going to go ahead and put a plus 16 right here. Because I know that a negative 16 and a positive 16 will cancel each other out. And then if I just add these numbers together, 47 and 16 would leave me with something like, oh, I don't know, 63. So for this next problem, the first thing I really want to do here, y'all, is combine my numbers. So 8 minus 2, that's just going to leave me 6 equals x plus 5. So remember, now I need to get the x by itself. Since I'm adding 5, I'm going to go ahead and subtract it because I'm trying to undo the process, right? And so 6 minus 5 is equal to 1. And same thing here. Let's see, 32 minus 11 is going to leave me with a 21 is equal to an x and a minus 4. And so again, since I have a minus 4, I want to go ahead and undo that by adding 4 to both sides. And let's see, 21 and 4, that's going to leave me with 25. Alrighty. So here's another one. 8.2 plus x equals 3.2. All right, so I'm going to go ahead and use my calculator here. So remember, this is a positive 8.2. So I'm going to go ahead and subtract it on both sides. Okay. And so guys, let me share this with you so I can show you on the calculator how exactly I'm going to do it. And let me pull this up. Here we go. Okay, so we have 3.2 minus 8.2. So I'm just going to type in 3.2 minus 8.2, and my answer is just a negative 5. Okay, so let me come back to my notes. There we go. And we said our answer was a negative 5. Okay, same thing here, y'all. I'm going to use my calculator. So first thing, I'm going to just write down this x. Now remember, these guys are on the same side. So I'm just going to subtract them. So I'm going to take my calculator again, 4.3 minus 2.6, 4.3 minus 2.6. That's leaving me with a positive 1.7. So positive 1.7 is equal to 3.4. Now, since I'm trying to get my x by itself, I'm just going to go minus 1.7 and minus 1.7. And again, y'all, on my calculator, I'll just do it like this. I'll just type in 3.4 and then minus 1.7. And I'm still going to end up with 1.7. All righty. So this next one here says x minus 1/4 equals 3/4. So remember, my first step, if it's a minus, I'm going to go ahead and put a plus. And I'm going to write it like this because I know that these will cancel, but I know that when I'm adding fractions, I have to have a common denominator. And the nice thing about this problem is, well, we do. So I know my bottom part's going to be 4. And then remember, all we got to do is add the numbers on top. So 3 plus 1 is also 4. But guys, remember, 4 divided by 4 is the same thing as 1. So one thing I want to point out, when you're doing your homework here out of 2.1, if you come up with a problem like this, and you get like 5/5, or 3/3, or 9/9, or 4/4, make sure you do divide it out and just put 1. Because if you keep putting the fraction, it'll say that even though your answer is correct, it's not simplified, and that's really the last part you really got to do for it. Okay. All right. Okay, well, that was 2.1. I hope that part made sense. Okay. So guys, let's go a little bit through 2.2. And 2.2 is the multiplication property of equality. And so what we're going to do here is we're going to figure out, how do I solve these types of problems, okay? And so remember what we're trying to do here. Anytime we're trying to solve, we're still trying to get the letter all by itself, okay? We're trying to get the letter all by itself. So the problem that I have here is 1/5 x equals 12. So guys, when I see this right here, what this really means is it really means 1/5 times x is equal to 12. And so when I'm trying to get the x by itself, I want you to think about the operation that I put here. We put a multiplication sign there, right? So we want to undo that. We want to do the opposite. And the opposite of multiplying really is to divide. But to divide by this number right here. So I'm going to put it like this, divided by 1/5. And I'm going to do the same thing here, divided by 1/5. But even though I can't see you guys right now, I'm pretty sure you're saying that doesn't look very pretty. I don't like the way that looks. And I agree, I don't like the way it looks either. But guys, if you remember, the way we divide fractions is we actually multiply by the reciprocal. So if I have 1/5 times x is equal to 12, the way I divide 1/5 is I multiply it by 5/1. So I'm going to multiply this by 5/1, and I'm going to think of that 12 as 12/1. Now, the reason why I want to do that, remember how we multiply fractions? We just go straight across. Okay? So 5 times 1 is 5. 1 times 5 is also 5. Here's my x. Okay? 12 times 5 is 60. 1 times 1 is 1. And then finally, well, this 5 divided by that 5 is just a 1x or just an x. And 60 divided by 1 is just 60. And if you notice, my x is by itself. So what I'm going to do is anytime I have a fraction in front of my number, I'm going to multiply both sides of that equation by the reciprocal, by the flip of that fraction, okay? So look, let's see, I think we have another one very much the same. Excuse me, let's see if we can do that here. So I have 1 over 9x equals -8. So the first thing I'm going to do is I'm going to say, what's the flip of 1 over 9? Well, the flip of over 9 is 9 over 1, okay? And I'm going to think of that 8 as 8 over 1. So again, when I multiply, guys, 9 times 1 is 9. 1 times 9 is also 9. Here's my x. -8 times 9 is a -72. 1 times 1 is 1. And again, these 9s are going to cancel. And -72 over 1 is just a -72. So one of the things that I want to point out is that when I multiply by the reciprocal, y'all, when we multiply by the reciprocal here, this 9 and that 9 are always going to cancel out, right? So I'm kind of walking you slowly through the process, like showing you, well, 9 times 1 is 9, so I wrote it right here, and 1 times 9 is also 9, so I wrote it right here. But that's always going to be the case, okay? And those numbers are always going to cancel out, all right? So here's another one. It's x over 12 equals -7. Okay, when I look at this problem, it looks slightly different from the ones that we did before, but it really is the same problem. I can think of x over 12 as 1 over 12 times x is equal to -7. So remember what we said we're going to do. If I see a 1 over 12, I'm going to multiply it by 12 over 1. Okay. Now, guys, remember, like I said before, this 12 and that 12 are going to cancel. So I'm just going to get my x. And then I'm going to multiply these guys together. So -7 times 12 is going to leave me with a -84. -84 over 1, it's still -84, right? So I'm just going to leave it like that. Okay. Are we doing okay so far? Am I going too fast? Am I making sense? Anybody got any questions?
You're doing a good speed. I like it. Thank you.
Okay, just checking with y'all. Okay, so guys, if y'all got any questions, please don't hesitate to ask. I'll keep checking in with you guys, but you know, if I do something that doesn't make sense, please let me know. This is why I'm here. Okay, so let's keep moving along then. Thank you for letting me know. All right, so here's the next one. X over 6 equals -2. So remember, I'm going to think about this as 1 over 6 with an x equals a -2. So my first step is if I see 1 over 6, I'm going to say, let me go by 6 over 1. Okay. And that 6 and that 6 are going to cancel. There's going to be my x. And then I'm just going to multiply these guys together, and that's going to give me my -12, right? And again, it would be over 1, but because it's over 1, it's just -12. All right. So these next couple of problems, remember, when I have a number in front of the x, and I'm going to write this out again just so that we don't forget, when I see something like this, y'all, that really just means 15 times x is equal to 60. So if I have 15 times x, remember, I'm trying to undo this. So the opposite of multiply is to divide. But it's easy for me to divide like numbers like this. It just looks ugly when we have the fractions, and that's why we did the reciprocal. But I really was dividing, right? Because divide says multiply by the reciprocal. So these 15s are going to cancel. And then, guys, y'all can just use your calculator, and if you take 60 divided by 15, you should come up with 4. So same thing for the next one here. It's 46 equals 2x. So remember, I'm going to divide both sides by 2 because I'm trying to get the x by itself. So that 2 and that 2 will cancel. And half of 46 is just going to leave me with 23. Okay. All righty. So for this next one here, it says negative 35 equals 21x. Okay, so we're going to do the same thing we did before. We're going to divide both sides by 21. Okay, so I know that this 21 and this 21 will cancel out. But if I were to take my calculator, guys, 21 and 35 don't divide out nice and pretty. But I can reduce this fraction, okay? So one thing I can show you here is, if you remember from before, here we go. Here's my multiplication table, and I'm just going to kind of try to clean some of this mess up here. Here we go. Okay, so we're looking at 21 and 35. So if you look, here's 21, here's 35. That means they can both be divided by 7. So 7 goes into 21 3 times, and 7 goes into 35 5 times, right? So we can divide them both by 7. And so we said 7 goes into 21 3 times, and 7 goes into 35 5 times. Because we had a negative here, we're going to keep our answer negative. Okay. One thing I want to mention, guys, people have asked me this question before. Does it matter if the negative goes right in the middle? Does it matter if the negative goes on the top? Or does it matter if the negative goes on the bottom? And the answer is it doesn't. All of these things right here, y'all, all of these answers really are, oh, come on, Pim, really are the same thing, okay? No matter how I do it, the negative, whether it's at the top, the bottom, or in the middle, it really all means the same thing, okay? So it's not important where you put it. You just don't want to put two negatives, right? If there's only one negative sign there, you're only going to put one negative sign. So let's see. So the next one here is 2x equals 0.36. So again, guys, this is going to be a calculator problem again, because I'm dealing with decimals, right? So those 2's will cancel. And I'm just going to take my calculator and I'm going to type in 0.36 divided by 2. And when I do that, I'm coming up with a 0.18. And let's see, this one here, guys, if you remember earlier, I said that when we have a negative x, it's really the same thing as like a negative 1x. So I'm really just going to divide everything here by negative 1. So those negatives cancel. And 32 divided by negative 1 is just a minus 32. Okay? All right. And so this next one here, I'm going to divide both sides by a negative 18. So those are going to cancel. First thing I notice, a negative divided by negative is going to be a positive number. So I'm not even going to worry about my negatives here. And I'm going to use my calculator to see if 18 goes into 108 nice and pretty. 108 divided by 18. And does it? It does. And it goes in nice and pretty 6 times. So my answer is just x is equal to 6. All righty. So this next one here, guys, same kind of process, right? I'm trying to get the x by itself. So I'm going to go ahead and divide everything by 2.5 because that is the number that's in front of my x. I'm always trying to get rid of the number in front of my x. And so if I take my calculator, I'm just going to do this here on my calculator. So I'm going to type in 0.5 divided by 2.5. And I'm coming up with a 0.2. Let's see. Here we go. Another calculator problem. Let me go ahead and divide everything by a negative 4.7. A negative 4.7. So again, a negative divided by another negative is going to be a positive. And I'm just going to take my calculator and I'm going to type in 14.1. I'm not even going to worry about the negative because I know a negative divided by a negative is positive. Divided by 4.7 is nice and pretty, the number 3. All right, same thing here. -6 and -6. Okay, so first thing I notice, a positive divided by a negative is going to be a negative number. Okay, so whatever I get, it's going to be negative. So on my calculator, y'all, and I'll show you how I'm going to do this right here. Quick second. Here we go. Okay. All right. So the number we had was 2.16 divided by a -6. Okay, but I already know that my answer is going to be negative. So 2.16 divided by, and I can go 6 and then hit the little negative like that and hit equals. And so my answer is a negative 0.36. Okay. So let me come back to my notes. Here we go. And we said a negative 0.36. All right. So guys, the difference in, like, say, this problem that we just did right here and this problem right here compared to this next one is, if these have decimals, I'm okay coming up with a decimal in my answer. But if I don't have decimals, then I don't necessarily want to write a decimal in my answer. So the number in front of my t is a negative 39. So I'm going to divide by negative 39, excuse me, on both sides. Okay. So those 39s are going to cancel. And I know that 39 doesn't go nice and neat into 36, but I also know a positive and a negative is going to be a negative number. So I want to see if I can reduce 26 and 39. And the way I'm going to do that is I'm going to come back to my chart, and I'm going to see, do I see 26 and 39 anywhere? Yes, I do. Here's 26 and here's 39. We can divide them both by 13. So 13 goes into 26 twice, and it goes into 39 3 times, okay? So when I come back here, you said 13 went into 26 twice and into 39 3 times. And so I'll leave my answer like this, okay? So again, guys, if it doesn't go in nice and neat, but I can reduce my fraction, then that's what I want to do. I don't necessarily want to write a decimal unless my problem has decimals to begin with, okay? So let's take a look at this one here. We have decimals, so I'm going to divide by a negative 2.8 on both sides. And those are going to cancel. It's going to leave me with a y. Guys, another thing, a negative over a negative is going to be positive, so I'm not even going to worry about that part. And I'm just going to use my calculator again. 3.08 divided by 2.8 equals 1.1. And here we go. All right. So let's take a look at this one. It says 5x plus 4x equals 36. Okay, we're going to combine like terms first. So those, when I add them together, y'all, gives me a 9x equals a 36. And now we can divide both sides by 9. And I'm coming up with x is equal to 4. Because 36 divided by 9 is just 4. All right, we're going to combine like terms here. So guys, remember, I have $3, but I owe you 9 means I owe you 6. Okay. So now when I divide both sides by a negative 6, those are going to cancel. Okay, so first thing I notice, a positive divided by a negative is a negative. And 6 goes into 18 3 times. Okay, and then this one here, guys, this is like the ones we did in the beginning of this section. If I have a 1 over 5, remember, I'm going to go with the reciprocal. 5 over 1 on both sides. 5 over 1. So that 5 and that 5 can cancel. I'll bring down my x, and then I'm just going to multiply straight across. So negative 4 times 5 is a minus 20. And let's see. Okay, so guys, 2.3 is going to be starting with material that we'll be doing this coming week. So I want to just kind of hold off on that because I know that the, you know, this other stuff is due by tomorrow night. So we got, let me see, we got about 7-8 minutes left. Do you all have any questions about anything that you want me to cover, or is there anything you want me to go over in the few minutes that we have left? I don't know if what we did right here, I mean, was that helpful to at least see how do I go through 2.1, 2.2? I don't know how many of you have had a chance to work those already, but again, all this stuff is due by tomorrow night. So if you haven't had a chance yet to do 2.1 and 2.2, hopefully what we did right here gives you a little bit of a better feeling of what it is you need to do, or at least how to approach the problems. Anybody got any questions about anything that you want me to go over or do anything? Any questions at all? You're good? Esmer, you're good? Excellent. Good. Okay. Well, hey, we can start a little bit early if y'all want, unless there's something else you want me to do. If you do have a question, please tell me, and I'm more than happy to go over it. If you don't have any questions, we can call it a day here. Are we good?
I'm good, thank you.
Okay, excellent. All right. Well then, guys, thank you all for showing up today. I appreciate it. Remember, if y'all have any questions, let me know. You're welcome. Guys, so remember, I know I answered a question over the weekend, or at least Friday afternoon. If you got any questions, guys, please don't hesitate. Send me a picture of the problem. I'll make a quick video. I'll send it out to everybody. You know, I'm happy to help you guys. So if you got any questions, please don't hesitate to ask. This is why I'm here. I want to help you guys get through this class, y'all. But thank y'all for coming. Y'all have a good rest of the day, and be safe out there, y'all.
Bye.
You as well. Bye-bye, sir.
Bye-bye. Y'all take care.